All right, exponent rule number 2 is called quotient of powers. Last time we had product of powers, so now it should make sense. We're dividing with two different exponents. So our general rule is a to the power of n, m over a to the power of n is equal to a to the power of m minus n. Now again, I'm going to show you why this rule works with an example. Let's go 3 to the 5th over 3 to the 3rd. So why am I allowed to just subtract my exponents? Well, I'll show you by expanding it like I did in the last video. This is 3 times 3 times 3 times 3 times 3. 3 to the 5th. On the bottom, I have 3 times 3 times 3. 3 to the 3rd. Now, you should know, if I have a fraction with the same thing on the top and the bottom, what's that equal to? It's a big 1. 1. 1. Those all basically just cancel out. What am I left with? 3 times 3. How do I write 3 times 3 like an exponent? 3 squared. Looking back at my original problem, what did I have to do? Really, all I had to do was subtract my exponents, combine my base into 1. So I'm ending up with 3 to the 2nd power. Just like in the last video, let's do some more complicated examples now, because they do get a little bit trickier. Example number 1. Let's say 18 x to the 4th, y to the 7th, over 3 x to the 2nd, y to the 3rd. So obviously right away it looks a little bit more complicated, but really what we can do is we can break this up into easier looking problems. So I'm going to split this up. Draw a line right down the middle. That makes it look like the fraction 18 divided by 3, or 18 over 3. Split this up. Now I have x to the 4th over x squared, and y to the 7th over y to the 3rd. I'm going to keep this like this. I'm going to treat this like 3 different fractions. 18 over 3, that's 18 divided by 3, that's just 6. X to the 4th over x squared, I can use my quotient of powers rule. I can simplify by just subtracting my exponents. 4 minus 2, that's going to give me x squared. Y to the 7th over y to the 3rd, same thing. Subtract my exponents because I'm dividing with the same base. So this is y to the 4th. And there we go, I'm done. 6x squared y to the 4th. Easy. You want to see one more? Let's do it. I can tell, you're like, I'm not done. I want one more question. Let's go. Negative 27. With this, I'm going to color code it this time. Negative 27 b to the 8th c to the 3rd over nine b to the 3rd, c to the 3rd. Similar looking problem actually, I just made it with the color, so I want to highlight exactly how I'm able to separate this. So I have coefficient over coefficient, the variable b over the variable b, and the variable c over the variable c, obviously with different exponents here. But I am still going to separate it into 3 different fractions. 1, 2, and 3 with the c's. Negative 27 divided by 9 gives me a whopping negative 3. B to the 8th over b to the 3rd. Subtract those exponents there. That's b to the 5th. And finally, c to the 3rd over c to the 3rd. That's a little weird. If I do my rule, 3 minus 3, that's going to be c to the 0th power. But do you guys remember that rule you learned way back, like 2 minutes ago? Well, if I do c to the 3rd over c to the 3rd, isn't that kind of like if I just have the same thing on the numerator and the denominator? Think about the fraction 5 over 5. What does that reduce to? 1. This It's gonna reduce to 1, so it's gonna like be -3 times b to the 5th times 1. I don't need to write the 1. That just cancels out. I'm left with my final answer, -3 times b to the 5th. Let's go.